Good morning. You are coming here for Calculus 2. My name is Michelle Kwon. You can call me Dr. Kwon. We will learn together and we will grow together throughout the semester. Let me talk about the general course structure and the course regulation. This is a face-to-face course. However, if you go to the course website, then you can see Zoom live lecture link. You can see here. The reason is I made that Zoom live lecture link for the students who may be sick or whatever the reason is. If you cannot come, then you still can join Zoom live lecture and ask me questions. And if you cannot join the whatever the live session will be, Zoom live or face-to-face, because you have a doctor's appointment or whatever the reason can be, then I will record all the lectures and post it online. So link is there. And if you go there, then I will post the video lecture recording here with the topics I covered for each day. So attendance for this course for every class will be mandatory. However, the way you attend the class will be somewhat flexible. This is a face-to-face course, so I expect all of you attend the class on site, but even if there is a reason you cannot come to the class or join live session, you still can watch the video recording. The reason that is important is for each class, I will give you 2 attendance code. Those will be 5 alphabetical characters, and you have to take attendance quiz. So however you learn will be somewhat flexible, but what is very rigid is you have to attend the class in a more general sense. Watch the video clip, come here, or join the Zoom live session. So if you go to the assignments, then as you can see, I made all the lecture attendance quiz. And if you click, then you can see the problem. There are 2 problems. So those are about code 1 and code 2. All you have to do will be you just type on the box. That is about the attendance quiz. So general regulation about the attendance quiz will be, I will give you 2 days. For example, if you, this is Monday's lesson, the deadline for the attendance quiz will be on Wednesday. And Wednesday's lecture, the deadline for the attendance quiz will be Friday. Ideally, I want you to take the attendance quiz right after the class, but for the students who are experiencing some difficulties, then you can watch it later, but you have to watch it within 2 days. Otherwise, you will start to be very behind. Do you have any question about the attendance and the attendance quiz regulation? I have office hours. My office is in the mathematical science building, and that is room number 403. I have office hours right after classes from 11:20 to 1:10 or 15. And then on Tuesday, I believe that is 10:30 to 11:20. You can check it on the simple syllabus. It doesn't open now. Our textbook will be OpenText textbook. You can find the books link here, but majority of students study for the course with the lecture note. The entire semester's lecture note is given here, and it'll be quite helpful if your writing is slow. And when you review, this lecture note will give you the accurate description of all the fact and you learned without typo, maybe. There will be weekly homework that will be given through Newton ITA. If you go to the assignment, then you can see integration by use substitution that is due on September 2nd. I think that is, I heard this time it is Wednesday, just probably September 2nd is Wednesday. Let me see. Yeah, every Wednesday, you will have homework deadline. Because of some functionality problem with Newton ITA, extension will not be given. So maybe it is better to consider the homework deadline is every Sunday, but if you cannot do it by Sunday, then the deadline, you have 3 more days to complete the homework. Usually, the homework must be covered in the previous week. Homework will be 15% of your course grade. And Newton ITA, you can purchase it through course materials by clicking opt-in. Then the charger will go to your course, your student account. You don't need any credit card or anything. Just opt-in, then you will get a lot of discount. Homework will be 15% of the course grade. There will be weekly quizzes. Weekly quizzes will be in-person quiz, and that will be given every Wednesday. So that is also in-class, in-person quiz. So even if you may miss Monday's class, on Wednesday you have to come. What I can tell you is the quiz will be given in the last hour. So my expectation is you have to come at least 10, 15 or 20 if you have something, then not to miss the quiz. Do you have any question about that? What is important is if you miss Wednesday's lecture, then you're missing the closed book quiz and you will lose point. Quiz will be 10% of the course grade. There will be 3 midterm exams. Those will be 50% of the course grade. Everybody knows that midterm exams will be a common exam, and everybody will take the exam at night at 8 p.m. on September 24th, October 22nd, and November 19th. Final exam will be 20% of the course grade. That is also a uniform final that will be given on Saturday, December 5th. If you're in SAS, then if you wanna get extension of exam time, then you have to reserve your seat in the SAS testing center. You have to do it at least a week prior to the exam. Otherwise, you cannot reserve it, and we will not give you extra time if you just come to the regular exam place. Do you have any question? We have a class discussion board, which will be Yellowdick. You can click here, and then you will go to Yellowdick. And what will happen will be on the Yellowdick, you can create or ask questions, course general question, and they can be mathematical questions also. And then what you have to do is you have to click here, ask your questions. And then you will write your question. But usually Yellowdick doesn't inform that someone posted something. So if your question is urgent question and is about course general regulation related question, then when you post it, you have to type at this. And then it will give me a notification and I will be able to answer your question quickly. There is an introduction about Yellowdick. That is about the discussion and that kind of asking question and some other discussion. But by asking question, you will not be able to collect any point. But if you join Yellowdick discussion, which I will suggest topics every few weeks, then you will get some point, and the accumulated Yellowdick points will be used when your course total would be nearby the borderline. So at the end of the semester, definitely that will be important. So by not joining Yellow Deck discussion activity, you will not lose anything, but you will not get any consideration at the end of the semester when your course total is slightly below the borderline of the better course grade. The most Yellow Deck questions, the discussion topics will be about the use of AI. So for this class, I encourage you to use AI to enhance your understanding and also generate some more problem for the extra practice if you have specific weakness. And so the Yellow Deck discussion activity will be about sharing your experience with AI. The required academic activity also give you the introduction about how to use AI. So AI will be used to strengthen your understanding and also reinforce prerequisite knowledge and also personalized review. I believe many of you have busy schedule and busy academic schedule, and it can be work schedule. So many of you might not be able to go to the math tutoring center or come to my office to ask me question in person, and most likely to study at night, and then you will be helpless. But if you know how to communicate with AI effectively, then you can get a lot of help. And so last semester, I encouraged students use AI and collected their opinion about their experience. And most of them had positive experience. So what we will do in the probably several weeks later will be writing your answers down about some mathematical problem, and then you will take a picture of your answer, and then I will ask you to upload to ChatGPT, Copilot, or Gemini, and ask how many points you can get by writing your answers in such a way. And that's one of the very common question that's about partial credit and whether your writing is organized pattern. The AI will be able to point that out very explicitly. So one of the assignments will be asking you to AI and then reflect on the AI's suggestion. So I will talk about that later. But what you have to remember is AI is an additional support tool. It doesn't replace my lecture or in-person tutoring or my office hour. So it is additional tool. And what I know is AI doesn't tend to explain visual concepts well. And the AI will be used mostly to strengthen your technical skill and prerequisite skill and further practice for the specific problems. So what I did here is I summarized all the prerequisite related formulas you have to clearly remember. And this is about calculus 1 related formula. And the next one is about trigonometry related formula. And the next one is about college algebra related formula. All of them are so essential. If you don't know any of them, then you will get into trouble. Especially in the middle of the semester, I noticed that many students were confused the integration formula with derivative formula and lost many points. So one of the weekly quiz problems will come out from any of these formulas. All of them are so essential and basic. And if you are confused with any of them, you would have trouble. So all of them must be the second nature, and you have to download all the formula sheet here and just go through it once a day. However, if you just remember the formula and don't know how to apply it, then you still can practice. I wrote the prompt here. And you can use AI to generate helpful problem and practice more. If you cannot understand, those are too abstract, and then you can ask examples to AI. So one of the important themes in this semester is learning how to communicate with AI effectively. That is related to the sequence of questions, especially prompt. So that is the way it communicates with us. So if you use effective prompt, then AI will be very useful. But if your prompt is not that effective, then AI will not help you greatly. It may be somehow helpful, but it doesn't have to be very helpful. So AI will be very important for this course. Do you have any question? So I don't consider using AI is cheating. As you know, the 70% will be of the course grade will be from exam. And 10% will be closed book quiz. So almost 80%. There will be some online quizzes also, but so anyway, so it's almost 80% that is from the closed book quiz. So I don't mind you use AI to enhance your understanding. And when you work on homework, of course, you can use AI if you cannot start the problem and whatever the problem is. And we will share our experience about effective use of AI and how you use it. Do you have any question? In the first week, what we will do will be review of the Calculus 1 material. The most important theorem you learned in Calculus 1 is fundamental theorem of calculus. Fundamental theorem of calculus says the integration is a reversing operation of differentiation. Let's suppose that we have a continuous function on the closed interval a to b, and g of x is defined by the function f of t by integrating and changing the upper bound of the integration. We have a function like this. We have a closed interval a to b. What we did is we varied the upper bound and we just think about the integration from a to x. And that is defined as g of x then the fundamental theorem of calculus says g of x is continuous and differentiable on the open interval a to b. More importantly, when we differentiate the function g of x, that'll be the original function f of x. Other important remark is if f of x is greater than 0, then integration a to x f of t dt is area under the curve. Maybe most of you remember how integration is defined. It was defined by the rectangle under the curve, and we refined and added refined rectangles. So when f is greater than 0, so entire graph is located above x-axis. When we think about the integration, that is the area under the curve. If we simplify the notation with indefinite integral and write large f of x as just an indefinite integral whose lower bound and upper bound is not specified. What I stated means this f of large f of x prime is the function before the integration. In other words, integration f prime of x dx is f of x. If you differentiate and integrate, then that is the function itself. Basic integration formula. That must be remembered very clearly. We have a constant c, and we multiply that to the function f and integrate. Then that equals the constant number times integration f of x dx. We add two functions and integrate. The result is the same as the sum of the integration of each function. This is just a basic principle from the integration. What is extremely important is, along with the derivative formula I stated on the first week academic activity, that you have to finish by Friday. You have to remember antiderivative formula. We have a power function, x to the nth power. When n is not -1, the entire derivative is x to the n plus 1 power over n plus 1. And 1 over x, if you integrate it, then you will get natural log of absolute value of x. If you have e to the x, then antiderivative will remain the same, e to the x. And if that is b to the x, then that will be b to the x over natural log of b. And we have cosine of x, then antiderivative will be sine of x. And if you integrate sine, then that'll be minus cosine of x. And if you integrate secant squared, then that will be tangent of x. And if you integrate secant x, tangent x, then that'll be secant of x. So, you know, derivative of secant is secant tangent. So secant tangent integration will be secant. One over 1 plus x squared. If you integrate, then that'll be tangent inverse of x. If it is 1 over square root of 1 minus x squared, then that will be sine inverse of x. So all those formula must be written in a separate sheet, and you have to review it every day so that you will not be confused with the formula. Excuse me, we are doing class and it's quite, yeah. Thank you. The next important theorem is net change theorem. Net change theorem means when we integrate the function which is differentiated from a to b, that is large f of b minus large f of a. In other words, the function value at b is f of function value at a plus integration a to b f prime of x dx. Just integrate the differentiated function. So that's the net change theorem. Let's do example. Let f of 0 is minus 2. The question is, what is the value of f of 1 when the graph of f prime of x is given below? We want to use the net change theorem. In this case, we have f of 0. So firstly, we have to think about what is the net change theorem. When we apply that theorem to this situation, f of 1 is f of 0 plus integration 0 to 1 f prime of x dx. So what should you do? We have to think about the equation of f prime of x that is given with a graph that passes through 0. So what's important will be identifying the slope, and then we will get the equation of the function f prime. The slope is change in y over change in x. When x increases 1, y decreases by 2. So y decreases by 2, x increases when x increases 1. So slope is minus 2. It passes 0, 0. So the equation of the function f prime of x is minus 2x. Now we are ready to figure out f of 1 because we know this net change theorem. So f of 1 equals f of 0 is minus 2 plus integration 0 to 1. F prime is minus 2x dx. So what is this? This is minus 2 minus 2 times integration 0 to 1 x dx. Everybody knows what the integration of x is, right? What is that? Huh? Yeah, right. So this is 1 power, right? So minus 2 times x squared over 2 from 0 to 1. So these two will cancel each other, and that is minus 2 minus 1 squared minus 0 squared, which is minus 3. Any question? A graph of f of x is given below. Find the value of integration minus 1 to 5 f prime of x dx. You can draw the graph any way you want, as long as the starting point and ending point are the same. This is y equals large f of x. What the question is asking you is integration of the derivative of the function. What is given here is the original function. In other words, just after integrate, you will get this large f of x function. When you apply the net change theorem, you will have f of 5 minus f of minus 1. F of 5 is 3 and f of minus 1 is minus 5. Therefore, we will end up getting 8. Do you have any question? That was about fundamental theorem of calculus that says the integration is the reversing operation of derivative. The next thing would be how what the corresponding rules are in derivative and in integration. What you learned is about substitution. Substitution is the corresponding operation, corresponding rule in integration that correspond to chain rule. Chain rule in calculus 1 was applied to the composite function f of g of x. Then the rule says that is outer function's derivative times inner function's derivative. That is the chain rule in derivative. What you learned was reversing operation is substitution rule. Let u is a function g of x, and let's say that is differentiable function. On the interval I, And f is continuous on interval I, so that's integrable. Then integration of f of x times g prime of x dx. So we go reversing way, then we will get this, right? And that can be written as f of u du. We will go this way, and the way we do it will be simplifying this one to u and g prime as du. So we can rewrite it, and then the given expression will be simpler, and you can perform the integration easier. That is a substitution rule. It is important to go through the example. Evaluate the indefinite integral. What we will mainly use in this example will be this formula, power formula. When n is not -1, integration of x to the nth power is x to the n plus 1 over n plus 1 plus c. In other words, derivative of a power function will be n times x to the n minus 1. The first problem is 18 times x squared times 6x cubed plus 8 to the 4th power dx. When we apply chain rule, it's not always the case, but the given integrand will be the product form of the function because the inner function's derivative must be multiplied. In this case, we have a power function whose inner function is a polynomial, not x. We have x to the 4th power, but we think about the composite function whose inner function is 6x cubed plus 8. And what is multiplied outside is the derivative of this inner function. So what we will do will be, we will express the inner function as u, just a variable. Then du will be 6 times 3 times x squared, which is dx. So that is 18 x squared dx. So this given integration can be rewritten as this part u, so u to the 4th power, and dh2 will become du, right? So it becomes u to the fourth power du, and then that'll be u to the fifth power over 5 plus c, and u is 6x cubed plus 8 to the fifth power over 5 plus c. Do you have any question? I think you're familiar with what I'm doing, right? The next one is integration. 5x plus 1 to the 100 power dx. It doesn't have any function that is multiplied to, but this is a complex function because of the power. You cannot expand that one by one. So we will use substitution. The given function can be regarded as a power function whose exponent is 100, and this is an inner function, so we will regard this one as u. Let's write u equals 5x plus 1, then du will be 5 dx. When we look at the integral, there is no other number outside of 5x plus 1 to the 100 power. We can see only dx, so we will solve for dx. So dx equals 1 over 5 du. Let's rewrite the given integration by using u variable. Then that becomes integration u to the 100 power times 1 over 5 du. So that is 1 over 5 integration u to the 100 power du. So that is u to the 101 power over 101 plus c. And we have 1 over 5 here from here. So we end up getting 505 on the denominator, and the numerator is 5x plus 1 to the 101 power plus c. It's important to write the original variable when you conclude the problem. The next one is integration 3x squared over x cubed plus 6 to the 7th power dx. In this case, power function is located in the denominator. And inner function of the power function is x cubed plus 6. So we will put that as u. And you observe that what is written on the numerator is related to the derivative of this u. So we are setting up correctly. U is x cubed plus 6, and du is 3x squared dx. So this part becomes du. So when we write the integration again with u variable, u is in the denominator and the numerator will be du. But let's write it down as 1 over u du. Then 1 over u to the 7th power du because of the 7. So that is integration u to the minus 7th power du. And we apply the integration formula. And what is that? U to the what power? U to the what?
-6.
Yeah, -6, right? Yeah, you have to remember over -6 plus c. So we can rewrite it as minus 1 over 6 times 1 over u to the 6th power plus c. And that is minus 1 over 6 times 1 over x cubed plus 6 to the 6th power plus c. Any question? The next one is integration. X times square root of 3x squared plus 1 dx. First thing you can notice here is this is a product function. X and square root of 3x squared plus 1 are multiplied. And what's under the radical sign? When you differentiate, you will get something related to x. Just that is the same as opt constant. So what we will do will be, we will put u equals 3x squared plus 1, and then du equals 6x dx. What we have here is x dx, but 6 is missing, so you have to solve for x dx. So x dx is 1 over 6 du. Let's rewrite this integration. Then it'll be integration. This is u, and x du is 1 over 6 du. That is 1 over 6 integration u du. This is first power. So that equals 1 over 6 u squared over 2 plus c. Actually, I have to write 1 over 2 power, right? 1 over 2 power. Any question about this? Because of this square root, right? Any question? So this one is 1 over 6, u to the 1 over 2 plus 1 over 1 over 2 plus 1 plus c. No question, right? Yeah, clear. So that's 1 over 6 times u to the 3 over 2 over 3 over 2 plus c. So we know a over b is a times 1 over b, right? So 1 over 6 times denominator is reciprocal is 2/3 u to the 3 over 2 plus c. And then this will be 1 over 9. What is u? U is 3x squared plus 1 to the 3 over 2 plus c. So nth root of x is x to the 1 over n power, and square root of x is x to the 1 over 2. Yeah, I forgot to give you. There is no space here. The next problem is integration x times x minus 6 to the 50 power dx. In this problem, what you notice here is this is a product function, and one of them is a composite function. The problem is the inner function, when we set this one as u, when you differentiate, it must be dx, it is not x. So that can confuse you. So, but we still can use substitution in this case, but in a different way. When you put u equals x minus 6, that is du, the du is dx. But by writing u equals x minus 6, what you realize is by doing so, I can write this part as u to the 50th power. And then, so we don't have to expand anything. X can be written as u plus 6. So this one can be written with u variable. X equals u plus 6. When you rewrite the given integration, we have u to the 50th power, and x is u plus 6, and dx is du. Any question? So that is integration u to the 51 power plus 6 times u to the 50th power du. So we will just separate like this. That just means we do term by term integration. Then we will have u to the 52 power over 52 plus 6 times u to the 51 over 51 plus c. And then we have to switch the variable back to x by replacing u by x minus 6. So that is u minus 6 to the 52 over 52 plus 6 over 51 times u is x minus 6 to the 51 power plus c. Any question? Let me remind you the trigonometric derivative formula. If you differentiate sine, then that is cosine of x. And if you differentiate cosine, then you will get minus sine of x. If you differentiate tangent, then you will get secant squared of x. And if we differentiate cotangent, then we have to put minus cosecant squared of x. And if you differentiate secant, then that is secant x times tangent of x. If we differentiate cosecant of x, then that is minus cosecant of x times cotangent of x. Again, you clearly remember these derivative formulas, and you should not be confused with integral formula. In this problem, what we want to do is we want to use this integral formula. But in this integral formula, that is 1 over 1 plus x squared, and then it must become tangent inverse. The problem is here, this is just this is not 1, so we have to get rid of that. To do that, we will take out 4. So integration 1 over, take out 4 times, and then open parenthesis, 4 times 1 will make 4. Plus we had 9x squared, but since we took out 4, we have to divide by 4, so that after we expand that out, we get 9 here. And then dx. So what we have is integration 1 over 4, 1 over 4 times integration 1 over 1 plus, what we want to utilize is, let me write down again. Integration 1 over 1 plus x squared dx equals tangent inverse of x. Okay. So what we did is 1 here. We made 1 here, and then the second term must be something squared. So 9 over 4 is 2/3 squared, and x squared is x squared. So I will write x here, and then put that in the parentheses and raise to the power, and then dx. By doing so, we could transform the given one into this pattern, right? So what happens here is this is just x, but this is x squared, but this is something squared. That means that's related to the composite function. So we will put the inner function, which is 3 over 2 x as u. Then du is 3 over 2 dx. We took out 1/4, and outside of the fraction, there is nothing other than dx. So we will solve for dx, then dx is 2/3 dx du. That is 1/4 integration 1 over 1 plus u squared dx is 2/3 du. So what is that? That is 1/4 times 2/3 integration 1 over 1 plus u squared du. And these will cancel each other. And we have 1 over 6 times tangent inverse of u plus c. The final step will be replacing u by 3 over 2. So that is 1 over 6. Tangent inverse of u is 3 over 2x plus c. Do you have any question? No question? Let's do integration sine of 3x over cosine squared of 3x dx. Fraction is involved. If you look at this, then cosine is raised to the power, and numerator is just a sign without any power. So the way we see this function will be cosine 3x squared. So I will put u equals cosine of 3x. Then what is du? Du, cosine's derivative is minus sine, but this is a composite function again. So we have to differentiate the inner function and multiply that to the derivative. So that'll be minus 3 times sine of 3x dx. We look at the given format, then we have sine of 3x dx. And so we have to solve for sine of 3x dx. So that becomes minus 1/3 du. The given integration can be rewritten as 1 over cosine 3x is u, and cosine squared is u squared, times sine 3x dx is minus 1/3 du. And then we can write the constant in front of integration, and u squared, 1 over u squared is u to the negative 2 power du. We apply the integral formula, and we have to add 1 to the power, then that'll be u to the minus 1 over minus 1 plus c. So minus minus will make plus, and so we have just 1/3. U to the negative 1 power is 1 over u plus c. So that is 1 over 3 times u is cosine of 3x plus c. Any question? No question? But we have integration minus x squared sine of 5th power 5x cubed times cosine of 5x cubed dx. Integrand is product of 3 functions. The highest degree power function is sine to the 5th power. Other functions are minus x squared times cosine of 5x cubed. What you can see from here is if you differentiate sine, then you will get cosine, but that is again a composite function. So derivative of the inner function must be multiplied, and the degree of the derivative of the inner function is x squared. So you realize that you still can apply the substitution technique. So you will put u equals sine of 5x cubed. Then du equals cosine of 5x cubed, but you have to multiply by the derivative of 5x cubed, which is 15x squared, right? So what you can say for this integral is we can rewrite the integral as minus integration sine to the 5th power 5x cubed times x squared times cosine of 5x cubed dx. So this one to the 5th power is u to the 5th power, and the remaining part consists of this part. I dropped the x here. So I will write this part as 1 over 15 du. Any question? So that will be rewritten as minus integration u to the 5th power times 1 over 15 du, right? This number can be written in front of integration. So that is minus 1 over 15 u to the 6th power over 6 plus c. That is minus 1 over 90. U is sine. So sine to the 6th power times 5 of 5x cubed plus c. Do you have any question? The next problem is integration 12x cubed times cosecant of 5th power x to the 4th power times cotangent of x to the 4th power dx. This looks pretty hard because when you identify the largest degree term, that is cosecant of fifth power. But when you differentiate cosecant, you have to get cosecant times cotangent minus cosecant times cotangent. But outside of cosecant to the fifth power, we have only cotangent. So we have to manipulate the given form so that we can use substitution. We can do it by breaking that into cosecant to the fourth power times cosecant. So I will rewrite the problem as cosecant to the fourth power, x to the fourth power, times cosecant of x to the fourth power times cotangent of x to the fourth power times 12x cubed dx. So what will happen will be, I will put u equals cosecant of x to the fourth power. What we know is the u equals minus cosecant x to the fourth power times cotangent x to the fourth power times 4x cubed dx. Any questions so far? So let's do substitution. I would put 12 in front of integration. So 12 integration cosecant to the fourth power, x to the fourth power will be rewritten as u to the fourth power. And this one times, what is this? This one. So I will just divide by 1/4 on both sides. Then we have 1/4 minus 1 du. Any question? No question? Okay, if you just write more, then it'll be clearer. So let's write down 1/4 and minus in front of integration. Then you have u to the fourth power du. So that can be simplified to -3 integration u to the fifth power over 5 du plus c. Not integration. Integration of u to the fourth power is u to the fifth power plus c. Let me write down again. That is -3 times u to the fifth power over 5 plus c. So that can be rewritten as -3 over 4, 5. U was cosecant x to the fourth power to the fifth power plus c. Do you have any question? Since this is the first class hour, I want you to be accustomed to how to take the attendance quiz. So you can go to the course website and put the code and see whether do it work. Yeah. Uh, this first week, I will not give you any quiz. The quiz will start from the second week. The default quiz range will be the things I cover in the previous week. Yeah. Here, that works, right? Okay. And um, I wanna go further. If you have any question and if you wanna talk to me, then you approach me and talk about that. Otherwise, I will see you on Wednesday.